All right, Algebra 1A students, welcome to part 1 of lesson 4.4. In this video, we'll be starting to graph function rules, we call them, which is basically graphing equations in two variables on an XY coordinate grid or on a graph, as we've been doing in previous sections of this chapter. And in this video, we're going to graph from a table of values. So we've seen tables of values a little bit before. We've seen graphs of tables of values. But now we're going to have to create our own table of values from a function rule equation that we are given. Okay? So if we look at this example here, they're asking us what is the graph of the function rule y equals -2 times x plus 1. Okay, just as a reminder, whenever we see -2 with an x right next to it, that's multiplying. So we're multiplying by -2 and then adding 1. So we're going to create a table of values here with x values. We'll find our y values, and then we'll plot those points on our coordinate grid right over here. Okay, and I always suggest getting in the habit of using as your baseline x values. If you don't have any good reason to do otherwise, use these 5 numbers as your x values. Okay, -2, -1, 0, 1, and 2. Unless they give you some kind of context, or we start talking about moving graphs around, which we won't do till later. But if you're just given a random equation, random linear equation, especially like this where it's just y equals something with an x, I would use these as your x values to start with, and then adjust if you need to. Okay. But essentially what we're going to do is once we list out these x values, what I'm going to do with each one is I'm going to take each one of these and I'm going to plug it into this equation where I see the x. Okay, so now what this is going to say is, well, -2 times another -2 plus 1. Well, -2 times -2, negative times negative makes a positive. This is a positive 4. Positive 4 plus 1 puts me at 5. Okay? And then I'm going to do exactly the same thing with the -1. I'm going to put that up in for x and see what my y value is. Okay, so now my equation says -2 times -1 plus 1. And -2 times -1, negative times negative is positive, so this is positive 2 plus 1 makes 3. Okay, then I do the same thing with 0. I put 0 in there. -2 times 0 plus 1. -2 times 0 is 0. Anything times 0 is always 0. Plus 1 gives me an answer of 1. Then I put a 1 in there. I do -2 times 1, and I add 1. -2 times 1 is -2. -2 plus 1 actually gives me a -1. And then I do the same thing here with 2. -2 times 2 plus 1. -2 times 2 is a -4. -4 add 1 gets me a little bit closer to 0. I'm now at -3. Okay? So now when we have this table of values, obviously if you don't want to, you don't have to put all this work here, but it can be helpful. But the thing we have to realize is that now this number here is my x coordinate of a point, and then this number over here is the y coordinate. Okay? So on my graph, I have -2 as my x value, and my y value ended up being 5. So on my graph, I go from my 0, 0 point, I go -2 in the x, and up 1, 2, 3, 4, 5 in the y, and there's my first point right there. Okay? Then I do the same thing with my next x value, which is this -1 right here. And my y value for that x value is 3. -1 in the x gave me 3 for my y. So I go from my 0, 0 point again to -1 and up 1, 2, 3. And there's my next point right there. Okay? Same thing when I go at 0 in the x. 0 in my x value gives me 1 as my y value. So from my 0, 0, I don't go anywhere in the x because it's 0. Up 1 in the y puts me right there. Okay? And there's that dot. Then I got a couple more points to do. 1 in the x goes with -1 in the y. So from my 0, 0, I go 1 in the x and then down 1 in the y. There's that point right there. And then 2 in the x goes -3 in the y, so I go from 0, 0, out 1, 2 in the x, down 1, 2, 3 in the y, right there. Okay? All right. And now that I have those points, I will connect all those points together. And I have graphed the line. Okay? I have graphed this function rule from a table of values simply by listing some x values and plugging them into my equation, my function rule up here, and getting a y value. Okay, so x values, y values turn into points. We find the y values by taking whatever x values we choose and plugging them in right there for x. Okay? The other thing that I'm going to ask you to do in this section is to basically do this same idea, but with some context, in a word problem, okay, in a real-world situation. Now, one important thing to keep in mind is that when we graph a real-world function, we need to choose appropriate intervals for the units on the axes. Okay? So, a lot of times you'll see that we won't actually have any negative numbers. Negative numbers won't make any sense for us. So then we'll only have to show the first quadrant, the types of graphs that we were doing before when we were sketching graphs previously. Okay? So this situation is exactly one of those situations where we're talking about the function rule W equals 146C plus 30,000, which represents the total weight W in pounds of a concrete mixing truck that carries C cubic feet of concrete. Okay? But they tell us here the capacity of the truck is about 200 cubic feet, which means there's no way that my C value can go higher than 200 cubic feet. Okay? C cannot be higher than 200 cubic feet in this case. All right? Now they want us to give them a reasonable graph for this function rule. Well, C is kind of in the same situation that my x was in before, right? A number times x plus 1. Now it's a number times C plus a number here. So C is going to go down on this axis right here, okay? C. And because they tell me a stopping point for C, they tell me a number that I get to go up to with C, I am going to make sure I get all the way up to 200 in my C value. Okay, I'm going to mark off right in the middle there. That's going to be 100. And then maybe I'll mark off again in the middle and go by 50s. Okay, so now my x values are going to change pretty dramatically because in my previous example, when I didn't have any context, I simply grabbed, remember, -2, -1, 0, 1, and 2. In this case, that doesn't make any sense. First of all, we can't have any negative numbers because a concrete mixing truck cannot possibly be holding negative amounts of concrete, right? And it cannot weigh negative pounds. So neither of these can be negative. That's why I start at 0 on both of these axes. Okay, start at 0 on both of them. All right. Now, a reasonable graph for this situation, I think I want to start counting my y-axis at 30,000 because that'll allow me to really show, the change here. Otherwise, it'll kind of look like a straight line if I don't. So what I'm going to do is I'm going to start at 30,000. But in order to do that, I have to show that I'm breaking my y-axis because I'm going from 0 and then skipping a whole bunch. So what I do is I just do a couple angles like that. And that's showing me that I broke a whole bunch, that I skipped a whole bunch of stuff. And now I can start counting at 30,000. Okay, that's 30,000. And then maybe I'll count by thousands here. Or maybe I'll figure out what I need to count by in a little bit. After I make a table of values, that's what I'll do. So I'm going to go over here and I'm going to make a table of values here first before I decide how high my axis needs to go. I'm going to put values of C in here and then values of W will come out for me. The values of C I'm going to choose are going to be the ones that I marked off here on the C axis. So I'm going to go 0, then I'm going to go 50, 100, 150, 200. Okay, so again, to find my W values over here on the right-hand side of my table, I need to take these C values and plug them back in up into my equation up there. Okay, 0 should be pretty easy because 146 times 0 is nothing, so I add 30,000 and that's exactly what I have. So 0 goes with 30,000. Okay, and then if I do that with 50, if I do 146 times 50 on my calculator, I get 7,300. Okay, and then I add that to 30,000, 30,000, I get 37,300. Okay, and then if I do it by 100, 146 times 100, and I add that to 30,000, now I'm at 44,600. Okay, and if I do 150 times 146, if I do 146 times 150 on my calculator, I get 21,900. I add that to 30,000, and I get 51,900. And then if I go at 200, 146 was my number in front of the C, times by 200, 29,200, add that to 30,000, and I get 59,200. Okay, so I need to make it almost all the way up to 60,000 here. So what I'm going to do after my break, starting at 30,000, I'm going to count up by maybe 5,000. Okay, so up here, I need to get to 60,000. Which means 30, that'll be 40, that'll be 50. So I'll cut each of those in half. Okay, so 30,000, 35,000, 40,000, 45,000, 50,000. Okay, and I'm just simply basing this, you guys, on my table of values over here. Looking at the W numbers that I have to get up to, I know I have to get up close to 60,000. Okay, so that's why I did my axis this way. Okay, but I did show this break here to show that I am skipping a bunch in my y-axis here. Okay, now I'm going to start plotting my points finally, and these C and W values from my table over here are really like my X and Y values were up here. Okay, so remember, in my X and Y values, I just went from 0, 0, went -2 in the X and up 5 in the Y for that point. So I'm going to do the same thing here. Starting at my 0, 0 point, I'm going to go 0 in the C and 30,000 in the W. 0 in the C, 30,000 in the W will be right there. Okay, and then at 50, I'm at 37,300, which is like halfway between 35 and 40,000. Then at 100, I'm up at 44, which is almost up at 45, but not quite. At 150, I'm up at 51, which is just over 50, well, almost halfway up, I suppose. Right about there. And then at 200, I'm all the way up almost at 60,000. Okay, so now I've plotted my points. Now I can connect them with a line. However, this line is going to be slightly different because in the last problem, I was able to put arrows on the end of my line, right? Put arrows on the end because there was no context here. They just said graph this function rule, so okay, I can put in whatever x I want. Here, I'm not allowed to keep going forever, right? Because as we talked about, I can't go negative with my x values, or my c values in this case. I can't go this way because there's no way my truck could have negative cubic feet of concrete, right? And then I also can't go any further than this point right here. I can't go that way because I had to stop at 200 because the capacity of the truck is 200. C cannot go higher than that. Okay, so please be careful and read the context when you have real-world situations and understand, am I allowed to keep going forever or can I not keep going forever? Okay, that's the big difference between these two types of problems. The overall key of this video, just to summarize real quick, is to understand that we can choose whatever values for our x variable or for our independent variable that we want, depending on the context. And then we just plug those into our equation, do some math, maybe on our calculator, and get out our other coordinates, then plot those points and connect them with a line. Okay? If you have questions about graphing from a table of values or creating your own, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.